and welcome to today's Generative Design Studies webinar. We are very pleased that you have taken the time to join us for this session. We hope that you find it interesting and of value to you. Please note that this session will be recorded. Should you have any questions during the session, please feel free to send us your questions in the chat box and we will attend to it as soon as possible. Thank you. The following content will be discussed during the webinar: a short introduction to who we are, introduction to generative design, and what are the ways to customize basic studies. Just to start things off, I would like to introduce to you our presenter and host for this session, Ane Barnes. Ane is an application engineer within the architecture, engineering, and construction industry. Ane is a professional architect with 5 years of experience as a BIM coordinator and over 10 years experience in the architectural sector. She is passionate about automating processes and procedures that impacts customer experience and deliverables. I'm Dominique, a strategic account manager within the architecture and interior design industry, and I will be co-hosting the session today. My main focus is on improving business management and business optimization. I will now hand over to Ane. Over to you, Ane. Thank you.
Thank you, Dominique, and good morning to everyone. Let's start with reviewing some key concepts surrounding generative design.
We have been noticing that professionals within the industry are starting to talk about generative design and how it could possibly impact businesses and workflows. Could you please tell us a bit more about generative design?
Of course. So the three concepts that I would first just like to review is generative design, computational design, and an algorithm. So generative design is an iterative design process that involves a program that will generate a certain number of outputs that meet certain constraints, and a designer that will fine-tune the feasible region by selecting specific outputs or changing input values, ranges, and distribution. Where computational design is an approach whereby a designer defines a series of instructions, rules, and relationships that precisely identify the steps necessary to achieve a proposed design and its resulting data or geometry. These steps must be computable, basically meaning they can be understood and calculated by a computer. And the last concept that I'd just like to review is an algorithm. An algorithm is a finite sequence of well-defined, computer-implementable instructions, typically to solve a class of problems or to perform a computation. Let's also just, before we jump into it, have a look at what's new in generative design. With our latest update, we now have two folders. We have the Autodesk samples folder that you can get the out-of-the-box studies, and we have the AEC generative design folder. You can also add additional custom folders to your choosing at the manage folder tab and add different folders, like say for different studies that you are doing or different types.
Thank you for the breakdown. Now that we have understanding of what generative design is, what would you say is the next steps for applying generative design?
Well, the starting point is definitely to work with the out-of-the-box studies and customize them. And today we will look at 3 ways to do exactly that. The 3 ways that we will look at is we will start with an out-of-the-box study, run it and see what we get. And we will see there's a small error, literally small, where the building scale doesn't come out through, and we will see how do we investigate this to fix it. Then we will add an additional output as cost to this script, and then we will see how we can add additional variables for the cost. For instance, if the floor area and the facade area cost varies. Let's start with an existing study. So over here, I'm just going to start with a normal architectural template, nothing custom done, and say, okay. Navigate to the Manage tab, create study. We'll navigate to the Autodesk samples out of the box studies and select 3-box massing. We'll name the study something descriptive. So we'll go with 3-box massing original, since we're just going to run it. We'll do the optimize method, leave everything as it is, and select generate. Now we'll see the computer is busy generating different outcomes. And the time it takes to generate these different outcomes, and you can see here at the bottom, it says 0 out of 10 or 4 out of 10 and how it's progressing. Really depends on your machine's computing power. And there we go, we have 10 out of 10 created. We can also filter the results by just hovering over this graph at the bottom and selecting, let's say, the height, or and clear the filters. You can view it in different ways, depending on your personal preference, how you would like to view the graph. And also filter this point one by just hovering a little, like selecting that piece and selecting on the x-axis, or selecting on the x-axis and the y-axis, and then you'll see the specific outcomes displays at the top. You can navigate to the different pages, like page 2, and see how these different outcomes looks. Here you can see the output values for that, and if you're satisfied, you can select Create Revit Elements. It will say element creation completed in Revit. Navigate to your Revit. We don't see anything, but that is because it's a mass that we created, and we need to select to show the mass. And there we have our teeny weeny little building. We see, obviously, it did create a mass, but unfortunately, the scale is not as desired. So we're almost there, but not quite. Even in 3D view, if you go and we lock the view, so we can add some annotations to it. Let's just name the view. Let's drop in some annotations. And we see this is obviously, it's quite clear in plan, and in 3D, there's an issue with our scale. So next what we need to do is we need to go and investigate this issue. We need to see, where did it go wrong? Why is the scale incorrect? So if we go and look at in our project settings itself, we can see that the distance is set to feet and inches, and that's not, well, it's not South African standard, so it's inches. So maybe there's something that we can look into. Length is in millimeters, so that's fine. But let's investigate the graph as well and look a little bit closer to it. And when we look at the input change variables, we see that it goes from 20 to 200. So obviously, if that's in millimeters, that's going to give us not the right scale building. So what we can now do is actually go to our project settings and set that to meters. Because if that is 20 to 200 meters, that will have a more desirable effect. So let's just change the settings inside our project. And let's rerun the study. We're doing exactly the same. Create study, navigate to our samples, 3-box massing, name the study, and generate. I'm just going to fast forward the generation process. you can select an outcome and select create Revit elements. Once the element creation is completed, you see this, our previous mass is still there, but we can zoom out, and there we now have our more desired outcome. We can verify it with just dropping in a dimension, and we see our building is now 150 meters high, which is more desired. Add just one more dimension in here, 128 meters. Great. So next we will add an output.
Before we start with the next step, could you please explain what is an output in the context of generative design?
Of course, an output is a setting you can add which can be used to validate the data after the algorithm has run. For example, if you'd like to know how the cost will be influenced by various examples, you can add a cost output. So the output will be a node that you add in Dynamo that you will right click on it and tell it is output. So you'll tell the node it's an output. And at the outcomes, you'll see the output will also be something that you can use to validate the data and to filter your results. So like for instance, currently our floor area and surface area is outputs that we get. But because I'm working with the out of the box study, we don't want to edit that study unnecessarily. So we would rather copy and paste it. So we're working with our own one. So if you want to go and work with that original sample study again, it's better that we have that one and we have our own studies which we've edited separately. So I'm just copying and pasting it from the samples folder to the AEC Generative Design folder, and also name it descriptively, just add to it, edit it, or webinar, or just for something that will make sense to you and your company. And with Dynamo, we need to kind of understand the steps that we want to do. So before we get there, we need to ask ourselves, how are we going to get there? And what's the process of getting there? And for cost, we need to think, okay, so it's an equation. To get to cost, it's an equation. And how do we get that equation? It's the floor area times the cost per meter square. And you need to add the surface area times the cost per meter square. That will give you that cost. Of course, it's simplified, but we've oversimplified the calculation for this example. So in Dynamo, let's open our script. And we're opening it in manual mode. So at output, what I'm going to do for this example is we'll just copy and paste an existing output, literally Control-C, Control-V, and move it a little bit out of the way. Hovering over it, we can see what type of node it is, and we see it's only a watch node. Can double click it and rename it so it's more descriptive for us, and if we later review it, we know what we are actually looking at. So let's add our calculations. I've also added the calculation here at the top, so just as a reminder of what we are aiming for, where we are going. So we're using some normal number nodes and rename them for the cost per meter square, and let's make it 10,000 Rand a meter square for this example. And this is just a fixed cost for now. We're keeping it easy. Add a multiplier, and you see I literally just type in a multiplier there on the left to search, and it gives me the multiplier node. It's not like I need to know exactly where it is situated in the library or whatever. I just type in the multiplier and it gives me a multiplier. So let's connect that at the Y, as you can see there at the equation what we are going for. And now we need to have the floor area and the surface area, and we want to connect that to our multiplier nodes. Just neaten up the space a bit. So because we're working with an out-of-the-box study, we can already take the surface area, which is already calculated for us, and add it at the 1, and the floor area and add it with the other, and that will now multiply the two with the cost per meter square. Okay, we still need to add the plus node. So let's go and just add the plus node. Literally just typing in there plus. It gives you that math operator. And now we can add those two together. To get a cost. And that's how we add that equation. We just want to make sure by right-clicking on this node that it is an output, that it will give us be an output in our generative design study. So that's why I just right-click there. Let's neaten up our space. So if, let's say, we look at it in a few months' time, or maybe some of our colleagues look at it, so it just makes sense. So everything is just nicely neatened up. We'll group these together, and we're going to color it the same coloration as the other outputs that we have there for floor area and visualization for the analysis nodes. And I'm deliberately creating basically its own group here for this output to keep it separate from the out-of-the-box outputs. So when you review this later, you know which ones you've added custom and which ones was out of the box. So you know where to interrogate the graph should you wish. Once we are happy, let's run it to see, we don't have any errors, great. We can continue, and here we can say update the study type. And it will say it's updated the study successfully. That's great, that's what we want to see. Select OK, and just save it. In Revit now, we can say create study. We are at our custom studies. There we see our 3-box massing webinar. And there we have our costs as a goal. And you can also set constraints for cost, but I'm going to leave it as it is, currently as it is, and select generate. Let's fast forward a few of these generations. And here you can see here we have our cost output. And now we can use this to validate the data, filter the data. We also have the cost there at outputs. Beautiful.
How would it work if the floor and facade unit costs are different?
That's a good question, and I actually just want to go in that direction. And we can develop this graph further to add a variable cost input. If you'd like to have a different cost for floor and facade, that means that's two things, so we need two variables. So basically where you can see where we are going is we want to add variables and constraints. This is what we're going to add. We're going to add a floor area unit cost per meter square and a facade area unit cost per meter square as a variable at the beginning, and also as a variable to validate the data that we will see over here. So let's navigate back to the Dynamo graph. And we started with just a number node, which has just 10,000, which didn't give us the option to edit it too much. So what we do need is we need an additional input node. And again, I'm going to copy and paste. So I selected Control-C, Control-V, copy and paste it, one of the existing inputs. And I need two because I want two variables. So I'm doing that, just repeating this. And I'm just hovering over it, and you see it's a number slider. So that's the original node it was made, and double clicking it and rename it for our own reference to know what we are working with. Rename it as descriptively as possible for your own reference as well as your team members' reference. And we'll repeat the same and rename this node as well. Now we can just adjust the data where we can set our own custom minimum and maximum values. You can set it to anything that you want and also set in the step increments. So let's, for this example, for the floor area unit cost per meter square, we'll make it between 1,000 and 12,000 Rand, and we'll keep the step in steps of thousands. And for the facade area unit cost per meter square, let's make this the minimum of 500 to 15,000, and let's make the step just a little bit different. So let's make steps in 500. So you see, if I'm moving the slider, that number actually adjusts in increments of 500, because that is the step that I've set it to increment in steps of 500. Whereas that one is set to step in steps of 1,000. That is actually what's happening there. Now we want to connect these to our graph, and to disconnect that number slider just in that place of that fixed number, we now want a variable, and that's the variables that we've set it to for our calculation. We can delete that node as we no longer need it. And neaten it up a little bit. We'll group these also, keeping the same coloration as the other input nodes, but as a separate group, so we can see which ones we actually did custom to the original script. All right, now we need to see if it's working, so let's select run. And no errors, great, we can continue. We still need to update the study type. And it says it's updated successfully. That's good news, and we can save it. When we navigate to Revit, we select Create Study. At our custom studies, there we have our 3-box massing webinar. And there we have our floor area unit cost per meter square and a facade area unit cost per meter square. Beautiful. We have our cost. And which we can also adjust if you'd like to, but I'm going to leave it as it is for now. And let's select generate. So obviously this generation process, again, it's depending on your computer's processing power. You can see as it creates more, we're now at 7 out of 10, 10 out of 10, there we go. Good. Now we can see here we have our different floor area unit cost per meter square and facade area unit cost per meter square, and you can use that to filter the data and to only show you those options at the top. Clear the filters and just play around with it until you get to one specific solution that is desirable for your design intent. You can also filter the data here at the top by filtering now with these output values, and you can make it from the least to the most or from the most to the least. By selecting that, toggling that button over here. And that, ladies and gentlemen, is basically what we wanted to show you today, is how to take a basic study, adjust it slightly. Once you've adjusted one piece successfully, try something else, Once you've done that, develop it further and then really just develop it further from there, and your confidence will grow. And that's the beautiful process of this. Some resources that we've used for this webinar, and yeah, thank you very much for joining us today.
Ladies and gentlemen, thank you once again for attending this webinar. We will now give it a few minutes for any questions. Okay, we've got one question. If you have a generative design study, can you only use it on one project?
That's a good question. No, you can use it multiple times. You can use it on several projects, and that's because that's what's nice about this folder structure that you can now set in place. For, let's say you have your firm is doing different kind of projects. You're doing hotel projects, you're doing offices, and maybe some schools. Maybe you have different graphs and generative design studies that you use for these different ones, and you can actually keep them in different folders and use it for those type of projects over and over again.
Then we've got another question that came in. Is there script samples available of this? This is very interesting and would like to try it on Dynamo.
Well, this is actually the example study that ships with the latest Revit, with the latest Revit and generative design. So I'm happy to share the script that we've done today. I'm happy to share it with any attendees. If you'd like to have that, you can just email us and we can share it with you. No problem.
All right, thank you, Anna. And then there's another question. Can you add an occupancy variable with that will influence the floor-to-floor heights?
Yes, definitely, and that will actually develop this graph so much more and make it so much more powerful. So you can definitely add occupancy variables that you will add at the beginning as inputs, and also your floor-to-floor heights will be other variables that you will add that could influence this script, and that would make it quite an interesting script actually.
Thank you. Are there any other questions? I believe that is all questions we have for today. Ladies and gentlemen, thank you so much once again. I hope you guys have a wonderful day, and thank you, Ane.
Thank you, Dominique, and yeah, thanks guys. Thanks for attending. I hope you found it helpful.